Hello dear students, we are continuing exercise 3.6 question number 1 and the third sub question of that question number 1. Okay, here in this question 4 by x plus 3y is equal to 14, 3 by x minus 4y is equal to 23. Okay, this question also we can solve, that is for x and y, by reducing them into pair of linear equations into two variables. Isn't it? Why? Because here the variable of the first term, that is x, is in the denominator. But here the second variable for y and y in the both equations, you can see that is in the numerator. So there is no substitution is needed for y. So we have to substitute only for this x in the denominator. That is 4 by x means 4 into 1 by x. Okay. So there we can give substitution for 1 by x as u. And there is no change for the y. Why? Because y is there in the numerator. So first of all you see that where you have to give substitution. Some problems we have to substitute for both x and y only when both are in the denominator. That concept is clear, children? Okay. So if you are substituting this 1 by x as u, the given equations become 4u plus 3y. I am keeping that term without any change because y is there in the numerator itself, equal to 14. So 3 by x means 3 into 3 by x is 3 into 1 by x and 1 by x is u. So 3u. Understood? So 3u minus 4y is equal to 23. Now see this pair. Now this reduced into the pair of linear equations in two variables. Understood? Now we can solve. Okay, here how can we apply that elimination method? Any one of the method you can apply, but I am doing this solving these equations by elimination method. Okay, so here see children, we are going to we are making the coefficient of u the same in both the equations. Then only we can eliminate that term. Understood? How this can be possible? Okay, that means we have to multiply, let it be equation number 1 and equation number 2. Okay, so equation 1 should be multiplied with the coefficient of u in the second equation. Okay, so with the 3. Here since the coefficient of u is 3. So what happens after multiplying? 4 into 3, 12. And in the next step, equation 2 should be multiplied with the coefficient of u in the first equation. So 4. That is clear, children? Now we are going to multiply equation 1. This indicator you should write. Okay, equation 1 whole equation should be multiplied with 3. Okay, so 4 3s are 12u plus 9y equal to 14 into 3. Okay, that is 42, 14 into 3. Okay, and we are multiplying equation 2 with the coefficient of u in the first equation. That is what we have written here. Okay, so with 4, so 12u minus, since here the sign is negative, so 4 into 4, 16y is equal to 23 into 4. Okay, we have to multiply each term. Okay, that is both LHS and RHS with the number 4. Here the coefficient of u in the first equation. Understood? Okay, that is 12, 1 carry 92. 4 2s are 8 plus 1, 92. Okay, let it be equation 3 and equation 4. Okay, then for eliminating that u term, that is from this given equation, from this 3 equation, that is equation 2. Okay, next we are going to eliminate this u term from both equations, from equation 3 and 4. How this is possible, children? Okay, here both are positive sign. You having same coefficient in both the equation, but in order to eliminate, both are positive. 12u, here also 12u. If you are adding, you will get 24. So our aim is to eliminate one of the variable. For that, we have to subtract. That you have to write here. Equation 3 minus 4 implies. Okay, that means we have to subtract equation 4 from equation 3. That is the second equation. You have to change the sign of each term, that is negative. Here this minus sign become plus. Here positive become negative. Okay, so hence the first term get cancelled. So positive and positive. So 9y plus 16y. Add the coefficients. That is 25y is equal to, okay, 42 and minus 92. Different sign. So take the difference. 92 minus 42 is 50. Okay, 92 minus 42, okay, 50, but it carries negative sign. 692 is negative quantity, so negative 50. Okay, so y is equal to negative 50 divided by 25, and this is equal to negative 2. Okay, so we got y as negative 2. Understood? And we have to substitute in one of the equation, that is equation number 1, in order to get u. Okay, after getting u, you can resubstitute so that you can easily get x. Our aim is to solve for x and y, because x and y are the variables in the given pair, in the given equations. Okay, so our aim is to solve x and y. Now we got y. Okay, so what can be the next step? We are going to substitute this y is equal to negative 2 in either 1 or 2. Okay, so I am going to substitute in equation 1. Okay, so from 1, okay, we are writing with respect to u. That equation we are going to write with respect to u, means we are keeping this u term alone in LHS. That is 4u is equal to, this is equation number 1. So we have to write the term in the RHS first, and positive 3y. When you transfer this from LHS to RHS, this become 3y, negative 3y. So 14 minus 3 into, we got the value of y as negative 2. So negative 2, isn't it? So this is equal to 14. This negative and this negative sign become positive 6. 3 2s are 6. Hence this is equal to 20. 14 plus 6. And this is 4u, not u. And from this you can get this u, that is 20 by 4, that is equal to 5. Now we have the value of 5, but how we substituted? We have 1 by x is equal to u. This is the substitution we made here in order to make this a pair of linear equations in two variables. So from this, okay, this x will be going to that side. So x is equal to, okay, that is 1 by u. Here what is u? That is 5. So x is equal to 1 by 5. So now we have value of x and the value of y. So x and y, x comma y is equal to 1 by 5 and negative 2 4y. These are the two values of the variables, that is x and y, that is given in the equation. Okay, so this is all about the third question. Now the fourth question. Here we have 5 by x minus 1, 1 by, plus 1 by y minus 2 is equal to 2, and 6 by x minus 1 minus 3 by y minus 2 is equal to 1. See children, here also, here the variables, see x minus 1, that x is in the denominator, and here also x minus 1 in the denominator. Okay, here y also in the denominator. Here in the second equation the y is also in the denominator. So first we are going to reduce the given equations into pair of linear equations into two variable by suitable substitution. Here what can be done, children? Because we are going to take this 1 by x minus 1. See, children, 5 divided by x minus 1. Okay, this is equal to 5 into 1 by x minus 1. Okay, so we are giving substitution for 1 by x minus 1 as u. So this term reduced in the form 5u. Okay, so that is the substitution. Put 1 by x minus 1 is equal to u. So this reduced in the form 5u. Okay, and the same way 1 by y minus 2. Here also 3 by y minus 2. Okay, numerator doesn't matter. You see the denominator of the two terms. Okay, that two terms in the two equations are the same, y minus 2, y minus 2. See here the first term, x minus 1, x minus 1 are the denominator. So we are substituting for the denominator. Okay, that is 1 by y minus 2. That is 1 by y minus 2. Okay, the variable is in the denominator. So we are giving a substitution for 1 by y minus 2 as v. Okay, so this reduced in the form 5u plus v is equal to 2. That is the first equation after reducing, after giving the substitution. This given equations becomes 5u plus y minus 2 is v is equal to 2. Here 6 by x minus 1 is 6 into 1 by x minus 1. 1 by x minus 1 is u. So 6u. So 6u minus 3 by y minus 2. That is 3 into 1 by y minus 2. 1 by y minus 2 is v. Okay, so 3v is equal to 1. Okay, now we are going to solve. So this is of the form pair of linear equations in the two variable. We have two equations in u and v such that here the u and v in the numerators. Okay, so we are going to solve. Here this equation, this pair can be easily solved. Why? Because here in the previous cases we multiplied this equation. We can mark this as equation 1 with the coefficient of u in the second equation, that is with 6. And the second step what we have done in the previous problems, that is the coefficient with the coefficient of y, first term, that is u, that is here 5, we multiply the whole equation and hence we made the coefficient of the u in both the equations the same. Understood? But here without doing that, here you see that in the after reducing that given equations into pair of linear equations into variables, you see that any one of the variable having the coefficient 1. If it is 1, you can easily solve for u and v. Why? Because here if you multiply equation 1 alone with this negative, this 3, that is the coefficient of v is 3. Okay, what is our aim, children? We are going to make the coefficient of one of the variable the same, not the sign. Okay, we are making, first we are going to make the coefficient, okay, that is its absolute value, that is the same, okay, without the considering the sign. So since here coefficient of v is 1 and 3, if you multiply with 3, you can make the equation 1 and its coefficient of v as 3. Okay, don't simply concentrate only for the first variable. Okay, you can make either the first variable or the second variable the same according to our convenience, our easiness. Okay, you see that which method would be better. Accordingly, you can make the coefficients the same. Okay, so here in this problem, I am going to make this coefficient of v, that is second term, that's same, by multiplying equation 1 alone with this 3, that is coefficient of v in the second equation, by keeping the second equation without any change. Okay, that is how I am going to eliminate v from these two equations. Okay, so I am going to write that now. That is equation 1 I am going to multiply with 3. Okay, so 5 into 3, 15u, okay, plus 3v is equal to 2 into 3, that is 6. This can be equation 3. And since there is no change for equation 2, I am keeping as it is, okay. And now see how this term can be get eliminated. Here now we have negative 3v and positive 3v. Here see in the previous cases what we have done, after making the coefficients the same, we subtracted because both having same coefficient with the same sign. Okay, so numerical coefficient was there same, but if you consider here in these two pairs, here both are in different opposite sign. Okay, minus 3v and plus 3v. So this will get eliminated only when we are adding this 2 and 3. That is indication, that is 2 plus 3 implies, okay, we are adding. So adding, there is no need to change the sign of each term. We are changing the sign only when we are subtracting. That point is clear, children? Okay. So here we are adding, that is 15 or 6 plus 15 is 21u. This term get cancelled when we are adding. So this is equal to, in the RHS, 1 plus 6 is 7 and u is 7 by 21. So both are the multiples. So 7 in 7 one time, in 21 3. So 1 by 3. So we got the value of u as 1 by 3. That idea is clear, children. And see, I already told which way, term, the coefficient we are going to make, that term get eliminated. The another variable we are getting first. So in order to get v, you can substitute here in the first equation, or we are going to write this first equation with respect to v. Okay, so we are writing from 1. Okay, I am going to write with respect to v. V is equal to, okay, RHS term we are writing first 2 and plus 5u is taking to RHS of minus 5u. Okay, that is 2 minus 5 into, what is u? 1 by 3. So 1 by 3. Okay, that is, this is equal to 2 minus 5 by 3. Isn't it? Okay, that is 6 minus 5 by 3. Okay, I am multiplying, cross multiplication, and you will have 1 by 3, 4. 1 by 6 minus 5 is 1, and in the denominator 3, that is v is equal to 1 by 3. Here we got u is equal to 1 by 3. But what is our aim? We should get x and y. Okay, so resubstituting, we for 1 by x as u and 1 by y minus 2 as v. Okay, so hence you will get here 1 by x minus 1 is equal to u. Okay, or here from this 1 by x minus 1 we can substitute u as 1 by 3. 1 by 3. Here again you can take the reciprocal on both sides, that is LHS or RHS, or this idea also you can apply. This one you can cross multiply, that is 3 ones are 3 and x minus 1 into 1, this one, or x minus 1 is equal to 3. X minus 1 cross multiplication is equal to 1 into 3, 3, hence x alone we are keeping here. So 3 RHS 3 minus 1 when come to RHS 1. So x is equal to 3 plus 1, 4. Okay, in order to get y, what we can do? We can substitute this x is equal to 3. Okay, and here we have 1 by y minus, here v is in now we need the value of y. Okay, for that we substituted v as y minus 2. Okay, that is from this, that is y minus 2, we have 1 by y minus 2 is equal to v, or 1 by y minus 2, we got v as 1 by 3. See here. So I am giving substitution for v, and the same idea. Okay, 3 into 1, 3 is equal to y minus 2 into 1, y minus 2. Okay, okay, I am keeping y alone here, this RHS, by taking minus 2 this side. So 3 plus 2, that is 5. That is y is equal to 5. Or you can directly take on the reciprocal. So y minus 2 is equal to the reciprocal of 1 by 3 is 3. So y is equal to minus 2, go to RHS. So 3 plus 2, 5. That both case also you can apply. So now we have the value of x as 4 and value of y as 5. So x comma y, okay, is equal to 4 and 5. This is all about that fourth question. Okay, that is we have solved for x and y, okay, by reducing them into pair of linear equations in two variables. Okay children, now we are moving to the fifth question. Now we are solving the fifth question. See children, here 7x minus 2y divided by xy is equal to 5. 8x plus 7y divided by xy is equal to 15. Okay, this problem can be reduced in the linear equation of two variable in two different methods. Either you can take this xy to RHS, so 5xy. Okay, so in order to make this RHS part the constant, you can divide the throughout with xy, or you can split this 7x minus 2y divided by xy with the xy. Okay, that is 7x divided by xy minus 2y divided by xy. Both are okay. Okay, so I am going to split this xy among two terms of the numerator, that is 7x divided by xy minus, I am giving this 2y divided by xy is equal to 5, because 5 is there in the constant, is there, should be there in the RHS part. Okay, and second equation I am giving this xy to both 8x and the 7y separately. Okay, 8x divided by xy plus 7y divided by xy is equal to 15. Understood? Okay, and in the next step, see, look into the new equations. Okay, that is 7x divided by xy. From this term you can cancel x. So it will become, that is 7 by y. Okay, after cancelling x from both numerator and denominator, minus, here see children, 2y divided by xy. Y get cancelled. 2y means 2 into y, and xy, x into y. Okay, then only you can cancel if they are connected by into. So you can easily cancel y from both. So 2 by x, this is equal to 5. Here the same way, x get cancelled. Okay, so this reduced into 8 divided by y plus 7y and xy, y get cancelled. So 7 by x is equal to 15. Okay, but after cancelling also, here in the denominator the variables are there in the denominator. Okay, and from there we can substitute for 1 by y. 7 by y is 1 by y. So 7 into 1 by y. So I am giving substitution for 1 by y as u and 1 by x. Here 2 by x is 2 into 1 by x. So 1 by x, in place of 1 by x you can substitute this as v. Okay, this is the substitution. Okay, put 1 by y as u and 1 by x as v in this equation. Okay, let us see what is the new pair of equations. Okay, that is 7, this 1 by y is u. So, 7u minus 2v is equal to 5. Okay, and 8 by y is 8 into 1 by y. So, 8u okay, plus 7v is equal to 15. Okay, usually we are taking 1 by x as u and 1 by y as v, but here first variable is y. That doesn't matter, children. If you are substituting y 1 by y as v and 1 by x as u, that doesn't matter. Okay, but since here y comes first, I just substituted for 1 by y as u, that's all. Okay, we can continue. So, see children, how can we eliminate? How can we eliminate one of the variable from this pair of linear equations in two variable? Okay, to eliminate means the coefficients of either u or v must be the same. But see children, here the first equation, that is 7, here is 8, 2 and 7. That means we have to make them equal. Okay, so let it be equation number 1 and equation number 2. In the previous case, there the coefficient of v was 1. So, you just multiply with the 3 so that you can make the, we made the coefficient of v the same in the previous case. But here, since 8 and 7, they are consecutive, they are not the multiples, and 2 and 7, they are not multiples. Okay, so what to do? Equation 1, in this case, this is the only method in elimination. Okay, so equation 1 must be multiplied with the coefficient of u in the second equation, that is 8. Okay, and the same way equation 2, the second equation must be multiplied with the 7, the coefficient of u in the first equation. That is the next step. Now what happened? The coefficient of u will be the same for both equations, so that you can eliminate easily. Okay, so 8 7s are 56u minus 16v is equal to 40, 8 5s are 40, 8 2s are 16, and equation 2 with the 7, LHS and RHS. So 8 into 7, 56u plus 7 into 7, 49v is equal to into 7, 15 into 7, 105, 35, 3 carries, 1 7s are 7 plus 3, 10, 110. Okay, now we have the coefficients are the same. Okay, so but here the sign is same. So we have to eliminate, you have to subtract. So let it be equation number 3 and this is equation number 4. So in the next step we are subtracting equation 3 and 4. Equation 4 from 3. So by sign changing, okay. So 56u and minus 56u get cancelled. 16 and 49 both are negative after changing the sign. So add and give negative sign, that is a loss of integers. So 6 plus 9, 15, 1 carries, and 5 plus 1, that is 4 plus 1, 5 plus 1, 6, negative 65v is equal to 105 minus sign and positive, 40 is positive. So take the difference, 105 minus 40, okay, so 565. So negative 65 because 105 carries negative sign. Okay, so implies v is equal to negative 65 divided by negative 64, or directly you can cancel negative sign, that doesn't matter. So you can reach into v as 1. This step is clear. See, normal substitution and solving of pair of linear equations by elimination method. Okay, this is the way to make the coefficient of u the same by multiplying with the suitable number. Okay, so in order to get u, what is the next step? From 1 you write equation first one with respect to u, that means we are keeping the term containing u alone in LHS. Okay, so from 1, children, from 1 This is equation number 1. I am keeping 7u. This is a term containing variable u is equal to 5 plus 2v, right? And 5 plus what we got, v as 1. Okay. So I substituted. So 5 plus 2 into 1, 2, that is 7. This is 7u. We need u. So hence u is equal to 7 by 7. U also 1. But what we need, children, we have to solve for x and y. So we can resubstitute for u and v as 1 by y and 1 by v. Okay. So that is 1. We have 1 by y is equal to u implies we need y, variable y. So y will be 1 by u, that is 1 by 1, that is 1. And also we have 1 by x is equal to v. So v is equal to 1 by x, or x is equal to 1 by v. But we got v also 1. Okay. So x is equal to 1. So x comma y, the values of the variables in the given equation are 1 and 1. Okay. So this is all about this fifth question. It's very, very important problem.